most important thing when it comes to port number. Okay, so hope I am making some sense to this part. Okay, feel free if you have any queries. Hope I'm clear. Okay, so I'm hoping that I have made things clear. Okay.
Asil, I have a small question.
Please.
So like particularly like for example like for my laptop I will be having like one IP address, okay, and along with that I should have a like 4-digit port number, correct? So
you should not be having a 4-digit port number. Let's say you are. I'll make it bit clear. Okay, so you are configuring a Hadoop cluster. Okay, you are configuring a Hadoop cluster, and you are configuring, and you are so when you configure Hadoop cluster, you give an RPC port number in Hadoop cluster. Okay, so if the
RPC, RPC you are calling it,
correct, RPC,
remote procedure call.
Correct, Sanjay, correct. Remote procedure call. Okay, so you are configuring a Hadoop cluster. Okay, so you define a RPC, that is remote procedure call for the cluster. So let's make it simple. Remote procedure call is nothing but the address for the cluster. So what is your home address? You would be having some address. If someone wants to come to your home, you would be obviously giving him the address. Similar way, you configure an RPC and you share the RPC to the client. So what happens is when you share the RPC to the client will be able to come into your cluster. If you don't share the RPC, the client won't be able to reach the cluster. So RPC is nothing but the address for the cluster. So RPC, you need to have the IP of the name node. Okay, so IP of the name node and the RPC port number is the address for the whole cluster. Let's say you have 10,000 nodes for the cluster. Okay, 10,000 nodes for the cluster. So if you want to access the cluster of 10,000 node, you should be knowing the IP of the name node and the RPC port number. If you are not aware, that is, if the client is not aware about the name node IP and the RPC, client won't be able to get into the cluster. Hope I'm making sense, guys.
Yeah, I got your point.
Okay.
They have like I mean production server. They do maintain any like standardization for this port number.
Yeah, I'll come to that part. So by default, okay, if you're just writing the name node IP, okay, if you're going to just write the name node IP, by default it would take 8020 as RPC port number. Okay, 8020. By default it would take 8020. Okay, let's say you want to give a random port number. You can configure it in the configuration. You have a configuration XML file. You can configure and you can replace the default 8020 port number to the desired RPC port number. That could be done by the administrator. We'll go through that as well. So the main point, what I'm trying to highlight here is, without the knowledge of IP and RPC port number, nobody can enter the cluster. So that is the importance of an administrator. So just understand from the perspective of an administrator, the power that particular job role requires. I mean, you are in charge of the whole cluster. It's like lock and key. You have the lock and you have the key. You lock it, you stay, you cannot enter. You have the power to remove nodes. You have the power to intimate clients. I mean, everything is under your control. So that is a huge responsibility, my friend. That is a huge responsibility. So it's your responsibility to make sure that nothing goes down or data is not being compromised. Hope I'm making sense, guys.
Yeah, that's clear now.
Okay, great. Umar, hope you're clear, bro.
Yes, please, sir. I'm clear. Yeah.
Okay, fine. So we understood about Linux. Okay. Now next, we'll be having 4 theory sessions. Okay. Before we understand the importance of theory, one second, guys. Okay. I'm sorry. So before we understand the importance of theory, we'll understand why is it necessary to take up theory session. Okay. So the first thing, the first chapter we have is Introduction to Big Data. What is big data? Simple, the root cause of the problem. You have a problem. What is the problem? Hadoop is a solution for some problem. So before getting into the solution, you need to understand the problem first, to be simple. So what we do is we first understand the problem clearly. What is big data? Why is it creating so much problem? I mean, we have issues with variety of data, we have issues with volume of data, we have issues in processing. So why is it creating so much heck? So we'll understand the issue first. Okay, once we are clear with the issue, now you guys will have a clear picture. Okay, so this is the particular problem, so how should we approach? Okay, so we have Oracle DB, we have Postgres DB, we have MySQL DB. Why are traditional databases not able to cope up with the issue? That is the second important question. Why should Hadoop come into picture? We have n number of traditional DBs out there. So why is traditional DBs not able to compromise the problem or address the problem? So we'll understand the drawbacks of traditional DBs. I presume most of them are working on traditional DBs, so you would be clear with that part. You should understand why traditional DBs are not able to cope up, I mean, not able to address the problem of big data. Okay, so once we are crystal clear with the problem and why traditional DBs are not able to address the problem, the ultimate solution, time being is Hadoop. And next one is why Hadoop. Okay, why Hadoop and how Hadoop addresses the problem. That is very important, right? Let's say we have a traditional DB installed as MySQL or Postgres. Postgres and MySQL is not able to cope up with the problem, but Hadoop is able to do that. Then the question arises is how Hadoop is able to do that. Okay, how Hadoop is able to process large number of data, how Hadoop is able to store large number of data without any discrepancy. So how is everything working? So simple, it's the architecture of Hadoop. So here we understand Hadoop clearly. Okay, we understand the architecture here and we understand the components. So when you install Hadoop, okay, Hadoop comes with lot of plugins. When I say plugins, in the sense you plug in components according to your requirement. Okay, so Hadoop is an architecture. You install Hadoop architecture. So it's like an extension box. You'd have used extension box for charging. So what you do is you have one plug. Okay, you connect the charger to one plug, and then you would find 4 to 5 slots installed inside the extension. So Hadoop is that extension box. You would be having different plugins inside Hadoop architecture. What are those components? I'll just give you an idea about those components. Some of the components are Hive, as Omar stated, Hive, Pig, Spark. Then we have Scoop, and then it keeps on growing. I mean, it's an open source community. Developers would contribute, and they would just they would be just contributing it to Apache Software Foundation. So what happens is, according to the requirement. So we'll just understand the importance. How come these components are being created? Okay. Okay. So we'll understand from the example of Hive. Okay. So there was a point when Hive was developed by Facebook. I mean, most of you would be aware by this point that Hive tool was developed by Facebook. Okay. So how come Hive came into picture? Okay. So there was an issue when the developers were facing hard time in Facebook. Developers were having hard time writing map reduce job. Okay, there was a point in when Hadoop came into picture. Okay, it was somewhere around 2007 or 2006. Okay, when Hadoop came into picture, the only way to process data is by Java. I mean, if you know Java, you can process data in Hadoop. If you don't know Java, you cannot process data in Hadoop. Simple. So what Facebook did was they came up with the idea. Facebook had lot of DB developers, Oracle DB developers, MySQL developers. So training thousands of people for Java is next to impossible. Okay, because when you cannot, there is a lot of cost incurred, and second thing is it is time consuming. You cannot expect a DB developer to learn Java within a span of 1 month, next to impossible. Let's say if he learns, it is very difficult to make it, I mean, process the data at that particular speed. Okay, so what Facebook came up with an idea is that Facebook thought, okay, so the only way to process data is by Java. So what they did was they thought of creating a layer on top of that particular processing. That is nothing but Hive. So what Hive does is you write the code in MySQL queries. You have the privilege to write the queries in MySQL. What Hive does is Hive will convert that MySQL into Java and it would process the data. So that made life a lot easier for Facebook developers. I mean, they don't have to learn Java. They can write the queries in MySQL. I mean, all the queries of MySQL will remain the same. It's all same query, select star from table, name, distinct, all those basic queries. So you write the queries in Hive. What Hive will do is Hive will convert those MySQL queries into Java and it will process the data. Simple. So that is how they came up with Hive. And what they did was they contributed Hive to the community. After developing Hive, Facebook developers contributed Hive tool to the community. That is something but Apache. So we state Hive as Apache Hive. We state Hadoop as Apache Hadoop. And everything is Apache. We have Apache open source community wherein all the tools are being deployed. Okay. So these are nothing but plugins. So we were into components. So we need to understand the importance of components. Components are nothing but plugins for Hadoop architecture. Let's say you have a requirement for MySQL in Hadoop. So as an administrator, it is your responsibility to install Hive and set up the Hive tool to the developer. If the developer is asking you to install Hive, you should be in a position to install Hive. So Hadoop architecture will allow you to do that. You just need to download the tar file and integrate along with Hadoop. Same can be done for Spark, Pig, and then it goes on and on. So every new tool is coming up in 1.5 months. So new tools are coming up. There was a point when MapReduce was the only way for processing data. They came up with Yarn. Yarn is nothing but yet another resource negotiator. Okay. Now they have come up with Spark. So Spark, what happens is everything happens on the fly. The difference between Spark and MapReduce is MapReduce will store the intermediate data in hard disk and then it would process the data. But what Spark does is Spark would do everything on the fly, everything on RAM memory. So just imagine the processing speed. So it would be skyrocketing. So Spark is currently being preferred by developers, and you can have a number of there are 3 to 4 languages through which you can process the data. We have PySpark, Python Spark, and then R programming, and then we have Scala. So there are different languages through which you have SQL Spark as well. You can write SQL queries and process the data. So Hive is being neglected. If you don't have to learn Hive because Spark itself has SQL. So now, I mean, maybe down the line in another 2 or 3 months, some other tool will come up. So this will keep on going. So as a aspiring learner, you should be in a position to learn things and move ahead. You should not stick with one particular thing and just that is not happening in IT for sure. According to my experience for past 2 years, you cannot survive with one technology, guys. You should be in a position to learn and grow according to the requirement. Tomorrow down the line, some other tool might come up. So you should be in a position to grasp things, learn and move ahead. So that is my particular suggestion. Okay, fine. So that is the importance of Hadoop. We have history, we understand the history, we understand architecture, and then components. So hope you guys are clear till this point. Okay, so hope everybody is clear. Next, when we say Hadoop, there are 2 pillars for Hadoop. Okay, what are those 2 pillars? First one is storage. You have a pillar for storage. And the second pillar is processing. Okay, you should be in a position to store large amount of data. At the same time, you should be in a position to process that data. What is the point of storing the data when you don't have processing speed? Just imagine you're watching a YouTube video which is consisting of which the time span of the video is just 5 minutes, and just imagine if it takes 15 to 20 minutes to load and view the video. Just imagine the mind state of the viewer. You'll obviously go insane because that is not expected. In spite of having the data, If you are not in a position to process, then there is no point in storing. That is what the system demands. If you have the data, you should be in a position to process it speedily. That is how Spark came into picture. Spark does everything on RAM. So people are moving into Spark. Now nobody is caring about MapReduce because, I mean, it's history. Nobody cares. Let's say something comes up down the line in another 2 to 3 months, people will move ahead. I mean, everything is speed. If you give me speedily, I would come over. That is the response of the customer. I mean, nobody cares about the data. I mean, let's think from the perspective of a customer. Okay, let's understand this particular thing. What is the importance of processing? You guys would be, I assume you guys would be using Facebook social networking site on a daily basis. So just imagine if you're watching a video, scrolling down or clicking something, just imagine if the site goes down or if it gets stuck at some point, you would get irritated. So it is the responsibility of Facebook to make sure that the clients are not hampered, that the speed is not hampered. Okay, you click, you get it. How is that possible, guys? I mean, in Facebook, there are petabytes, zettabytes, and I won't say zettabytes, I would say yottabytes. There are yottabytes of data residing in Facebook. So just imagine you click something, you get at not even 1 second, hardly fraction of seconds, depending on your bandwidth. You click something, you get it right there. So what happens is you have yottabytes of data residing inside Facebook servers, residing in different countries. You click something which is residing among those yottabytes, it would go, it would fetch, and it would retrieve within a fraction of not even a second. Hard to believe, but that is the fact. I mean, that is how everything is moving ahead. So just imagine the importance of processing. I just want you guys to understand the importance of processing. It is not just about storage. There is no point in storing if you don't have good processing speed. You guys agree with me? Hope I'm making sense, guys. It should not be one guy talking. I want you guys to interact as well. Yeah,
that's absolutely correct.
Correct. Okay. What about Umar? Do you share the same view, or do you have any other view on?
Yes, I agree. Like, unless we didn't deliver the data properly to the client, like, even though if whatever the technologies, they say no.
Correct. Okay. So there is no point in storing if you don't have processing capacity. Okay. So the main challenge when it comes to big data, by now you would have understood, the main challenge for time being is processing and storing. Okay, which obviously traditional DBs are not able to compensate. To be frank, I mean, you would have known by this time that traditional DBs are not able to compensate that particular problem. If they would have, if they had some strategy, means Hadoop would have come into picture. If traditional DBs had provisions to face all these problems and address this problem, Hadoop never would have come into picture. The reason Hadoop is able to cope up with the issue is because Hadoop has some provision. Okay, let's not get into the architecture for time being. Just understand the fact that Hadoop has some provision to do this particular job, that is to store and process the data. So that is how Hadoop is able to come into picture, and Hadoop is able to address the problem. Okay, so first chapter, I mean the fourth chapter would be about storage. Storage is nothing but Hadoop distributed file system, and that is where the data is residing. So you should understand clearly the importance of HDFS. So we'll get into the core part. Okay, what do I mean by core part? Core part in the sense okay, so core part in the sense I have a data. Okay, so what is a data? Data is nothing but blocks. Okay, in Linux file system you have blocks. We get into the file system level. Okay, when I store some data, let's say I store 1 GB of data in my system. Let's not get into Hadoop for time being, guys. A small note from my end. It's 8:58 for time being. Do you mind stretching till 9:30? I'm really sorry. I mean, things got delayed. Let me know if you have any issues. We are expected to close by 9. Unfortunately, I don't think we'll be able to make it by 9. Is there any problem if we stretch till 9:30?
Yeah, I'm okay with that.
Arun, what about Arul, Sanjay, Satish?
Okay, Ji, no problem.
Okay. Arul?
Yeah, I'm fine with that.
Okay. We have another student, Arul, A-R-U-L. Arul, could you just open up? Hello, Arun. Do you mind speaking up? Yeah, Arul, you could speak up. Just introduce yourself. Am I audible, Arul? Okay. Okay. No problem. No problem. I guess you have hard time with the network. I guess there's some network discrepancy. Okay. No problem. We are running out of time, guys. I'm sorry. We'll first close the session. So welcome, Arul, from our end. Uh, we'll we'll discuss the topics for time being as we are running out of time. Okay. Hope you don't have any issues listening. Okay. So Arul is on chat box. Let me just check. Okay. So Arul has stated that he's having some issues with audio. Go ahead. Okay. Fine. Okay. So we are discussing about processing, correct? About how the data is processed and the importance of processing. Okay. Sorry, we had a discussion about the storage. Okay. So we'll get into file system level. When I say file system level, I have 1 GB of data residing on my computer. Okay. Let's not take huge data. We'll take small. We'll take 1 MB. Okay. So 1 MB of data, as a customer, as a client, you could view 1 GB of data or 1 MB of data directly on the screen. Okay. But when you get into file system level, it is actually segregation of lot of blocks. So there are n number of blocks residing in the hard disk. Okay. So what happens is these blocks would form a file. Okay. So there is default block size. So what happens is you segregate the block and then you form the data. So same goes with Hadoop as well. In Hadoop file system, you need to understand the importance of blocks. Without a proper understanding of blocks, you won't understand how the data is being stored. Okay. When I move 1 GB of data from one computer to another computer, lot of things are coming into picture. From a customer's point of view, it happens just within a fraction of a second. But you should be in a position to understand what happens in the background. Now, why is it important to understand what happens in the background? It's simple. If you don't understand what happens in the background, you will not be able to fix the problem. If you want to fix the problem, you need to understand the things that happens behind the curtain. Okay, so we'll understand block storage. Okay, and then we'll understand daemons. What is the importance of daemons? How daemons will come into picture, and anatomy of file read and write. As I stated earlier, that everything happens on distributed file system. You have, when you write data, you're not writing on your local system. When I write something on HDFS, obviously I'm going to bypass n number of computers, my router, my data is going to pass through my computer to my router to n number of computers, and then to the destination node, and then it is going to work on the data on the file system level. Okay, so anatomy of file read, anatomy of file write, how data is written, how data is read, everything in detail from storage perspective. Okay, so once we are done with, once we are crystal clear with the understanding of storage, we'll move ahead with processing. You should be in a position to process. As we stated earlier, the data should be processed within a fraction of a second. So obviously a lot of things will come into picture for sure. So we have will understand MapReduce. So initially when they introduced Hadoop, they came up with the idea of MapReduce. MapReduce is nothing but mapping the data and reducing it to one data. Umar would be aware of processing for sure, because I mean, developers, what they do is they run job on cluster, and what happens is everything goes on mappers, and then mappers would segregate the data to one to reducer, and reducer would aggregate it and show it as output. So initially when Hadoop came up, they had MapReduce for processing. So there were some drawbacks with MapReduce. We'll discuss in detail the drawbacks that they had encountered. So what they did was they came up with YARN architecture. YARN is nothing but yet another resource negotiator. So there are a lot of other components which have added in YARN, and they have, it's like next level of MapReduce. We can state as MapReduce version 2. YARN is nothing but MapReduce version 2, where the problems of MapReduce were addressed, and they came up with YARN architecture. So now we have Spark. So it's the next level of YARN. So as I stated earlier, down the line, something new might come up. So this is how things goes. Okay. Okay. So after completion of processing, we would be having a clear picture about the, okay, by the end of chapter 5, we would be having a clear picture about one, the problem, that is big data. Second, how Hadoop addresses the problem of big data. Third, what are the two important pillars of big data, that is HDFS and MapReduce. So how HDFS works from file system level, and then how processing happens on network. Okay, so by the end of chapter 5, we'll be clustered clear with all the topics. We won't be getting into practical, but you would have a clear idea about how things work. Okay, why Hadoop came into picture, how come traditional database is not able to compromise. All those questions would be cleared by the end of chapter 5. Okay, so after having a clear understanding, you would be moving ahead with practical. Okay, from chapter 6 onwards. Okay, from chapter 6 onwards, it is complete practical. We would be having a theory session in the initial 5 to 10 minutes, just to give you an idea about the topic that we'll be dealing, and then core practical sessions. Okay, so chapter 6 is single node installation. Okay, so single node installation is nothing but installing Hadoop on one single machine. Okay, so we'll be installing Hadoop on one single machine, and then we'll see how things work. We'll understand it clearly. We'll be getting into, I'll just give you an overview about the topics that we'll be dealing, the subtopics for chapter 6. By this point, okay, I want all you guys to be crystal clear with Linux commands. Okay, so you have a span till chapter 5 to go through your commands. So I want all the Windows guys, those who are familiar with Windows, by this point, by chapter 6, you should be in a position to work with Linux. You should be in a position to work without any issue. I mean, you should not be Googling while working. So you have, I mean, somewhere around 2 to 3 weeks span. And I guess that is more than enough for you guys to get hands-on with Linux. Okay, so by this point, you should be in a position to work with Linux. I mean, all the commands, basic stuffs. So I guess you could do that from your end. No, not a big deal. Okay. I'm sorry. Okay, so we have a single node installation where we install Hadoop, and everything works on command line interface. As we stated earlier, we used to handle Linux trainings, that is Hadoop trainings, on Ubuntu. Ubuntu is nothing but a Debian distribution for Linux. So Arun came up with the idea of installing CentOS, and I would recommend the same, because when you get into company, you would be forced to work on CentOS, and there is not much difference with CentOS and Ubuntu. There is hardly some command which would differ, like you have a yum install, and in Ubuntu you have sudo apt-get. So there are slight changes with the commands, but most of the commands would remain the same. So what we did was we came up with Arun's idea, and I would recommend the same, that you guys install CentOS. Okay, CentOS on your system. CentOS is nothing but a distribution of Red Hat Enterprise Edition. So they have came up with a flavor of Linux named as CentOS, and most of the companies would be using Red Hat Enterprise Edition or CentOS. So I want you guys to get familiar with CentOS. Okay, don't get into Ubuntu. If you have Ubuntu, just uninstall Ubuntu and install CentOS, because we will be working on CentOS completely. Okay, and second important thing, this was stated by Arun. We had a discussion 2 days back. So he had installed the GUI version of CentOS. Okay, never install GUI version of CentOS, because your laptop would hardly be having 4 GB or 6 GB of RAM. Okay, let's say if your laptop is having a system configuration of 4 GB RAM, if you install GUI version of CentOS, it would ultimately get stuck and you would have hard time working on CentOS. So always go with minimal installation. Minimal installation means it will only come with the command prompt. You won't have anything apart from the command prompt. Anything, any operation you have to do, you will be forced to do via command. You don't have those beautiful GUIs. So don't install GUI interface for CentOS. Go with minimal version and install minimum 3 to 4 clones of CentOS on your VirtualBox, because you're going to do cluster installation on one machine. Okay, so what we do is we install 4 to 5 clones. Maximum we can go with 4, not less than 4. We cannot have 2 or 3, because for the whole Hadoop syllabus, we expect minimum 4 clones of CentOS. We need 4 machines. That is the minimum expectation. Okay, for single node, it's just 1 machine. As we come to cluster, we expect 4 machines. Okay, so 4 clones of CentOS, that is minimal version of CentOS. Am I clear, guys?
Basil, what was the configuration you will expect for like installing this 4?
Okay.
Means like what are the expectation of configuration for the laptop?
Configuration would be i5 processor would be good. I mean, coming to processor, it would, we expect i5 processor, and then 4 GB of 4 to 8 GB would be good enough to start with. That, I mean, if you can have 4, if you have 4, then I would recommend you to upgrade it to 8. 8 GB is the best requirement that suits our issue. Okay, so 8 GB of RAM, i5 processor, 500 GB of hard disk could be good enough to work with.
Okay, that's good.
Okay, so make sure, guys, if you have issues with hard disk and processor, you can compromise on that part. i3 processor or 200 GB of hard disk is not going to matter much, but 2 GB of RAM or 4 GB of RAM would be a concern. The reason I'm stressing you guys on the RAM is because when you install VirtualBox, you'd be installing clones. When I say clone, in the sense you install the operating system on the VirtualBox. Okay, now an operating system would be expecting minimum of 1 GB for sure. Okay, minimum of 1 GB for sure. Okay, so if you have 4 clones of CentOS, okay, what I did is I have configured minimum 1.5 GB for one clone. Okay, so somewhere around 6 to 7 GB would be for your virtual machines. Okay, and rest of the GB of RAM would be assigned to Windows, because Windows will also need RAM memory, right? So minimum 8 GB of RAM is recommended, guys. If you have 4 GB, then you will have to cut down your clone machines. Then you can only go with 1 or 2 clone. Okay, what we need to make sure is it should not get stuck at any point. When you work, it should be smooth. I mean, when you move from one machine to another machine, it should not take 1 minute, 2 minutes. If it is falling short of memory, what happens is it will get stuck at any point, and then you are forced to stop it. Then it would consume a lot of time, guys, and you would get irritated. I don't want the same thing to happen. So we'll make it crystal clear. Go with 8 GB of RAM, i5 processor. We can compromise on i3 as well, no issues. A hard disk doesn't matter, because we're not going to load huge amount of data. We are going to do a demo, right? So the main concern is the RAM. Okay, RAM should minimum be 8 GB. Hope I'm making sense, guys, and hope you guys are clear on that part. Okay, so hope you guys are clear. Fine. So a single node is just installing on one machine. Okay, we'll install on one machine, and then we have HDFS DFS commands. HDFS DFS commands is you have Hadoop installed on the machine, and now you are going to work on the cluster. Like simple, I install Linux on the machine. Okay, I install Linux on the machine, and then what happens is, one second, guys, just one second. Sorry, guys. So what we do is, let's say you install Linux on your machine. Okay, after installation of Linux, what you do is you do all the file system operations, right? File system operations in the sense you create a directory, you delete a directory, you copy file, move file. Same goes with Hadoop as well. Same goes with Hadoop as well. What you do is, you, after installation of Hadoop here, what is HDFS DFS commands? HDFS DFS commands is working on the Hadoop installation. We have Hadoop installed. Now we create directories, we delete directories, we copy files, we move files, we do all sort of operations on the cluster, on the single node installation, not on cluster. Okay, cluster is nothing but connecting one or two machines, is nothing but cluster. So after HDFS DFS commands, we'll get into cluster installation. Now this is where the clone thing is coming into picture. We have 4 CentOS clones installed on VirtualBox, right? What we do is, we connect all the VirtualBox clones into one cluster. Same would happen in physical machine. There is no difference with VirtualBox and physical machine. When you move into company, there would be somewhere around 50 to 60 machines, and then you would be doing it on physical. But here we are doing on virtual machine. The configuration, everything is going to remain the same. Nothing is going to differ. When you get into company, the only thing that is going to differ is the number of computers. When you get into company, you would be having somewhere around 50 to 60 computers depending on your cluster requirement. So the configuration will remain the same. The only thing is the number of nodes will increase when you get into production environment. Okay. So chapter 8 is cluster installation. So this is the core part of the course, because this is what you're going to do. First step of an Hadoop administrator is he should be in a position to install Hadoop on cluster. Okay, so given a cluster of 5 to 6 machines, he should be in a position to install Hadoop on all the machines. Okay, so this is the core of installation. From here on, you're going to get into the core part. Okay, next, chapter 9. Chapter 9 is checkpointing. I'm sorry, guys. So checkpointing is nothing but we have data. Okay, so in order, let's say you have a book of 500 to 600 pages. Okay, how would you identify the chapters? Let's say I want to get into chapter 6 of that particular book. Okay, so without an index page, it is very difficult to get to chapter 6. You can get to chapter 6 by going through all the pages. You would find a hard time. So if you have an index, you can just see the page number and you can get into the required chapter. Same goes with data. You have data residing in HDFS. Now, where is the data residing? What is the amount of data, space of data? Everything would be stored in the master machine, and the name of the file where the data is stored is metadata. So metadata is nothing but information about your data. If the metadata is lost, no point in having data, to be frank. I'll give you an importance of metadata. Okay, let's say I have 500 TB, 500 terabytes of data residing in HDFS. Okay, just understand this particular thing clearly, guys. The importance of metadata. Okay, let's say I have 100 TB of data residing in HDFS. Okay, so the metadata would be comprising of hardly, let's say, 10 MB. 100 TB data, metadata would be just 10 MB. Okay, if by some chance, if you lose 10 MB data, that is the 10 MB metadata, I'm sorry. If by chance, if you lose 10 MB metadata, it's similar of losing 100 TB data. Hope you guys are understanding. Without metadata, you cannot access data. So 100 TB data, the places where the data is residing and all those stuff should be residing inside the metadata. If you lose the metadata, okay, Satish is having a query. Address of the data is called as metadata. Okay, Satish. Yeah. So Satish has stated that address of data is called as metadata. That is correct. Address of data is metadata. So if you lose the metadata, ultimately you end up losing data. So as an administrator, you should have an extra care on metadata. Make sure that the metadata is not lost. If you lose metadata, then ultimately you end up losing everything on the cluster. Okay, so we have a whole chapter to understand how things work. Okay, here this is all about the metadata. What are the provisions? Hadoop has some extra provisions for metadata. Okay, the developers were well aware about the problems that would come up. Okay, so they have a provision to safeguard metadata. So one whole chapter to understand the importance of metadata and how to safeguard it. because you need to replicate the metadata. You need to do something on top, because you cannot compromise on metadata, guys, because the moment you compromise on metadata, the whole cluster would be facing downtime for sure. Okay, so you can never compromise on metadata. So we have some provisions to safeguard metadata. We'll understand everything clearly on chapter 9, wherein we get into metadata stuff. Okay, after proper understanding of okay, till this point, okay, we'll understand till this point. Okay, till this point you would be in a position to install Hadoop on one single machine. Okay, and then you would work on the cluster. That is, you would work on all the operations on cluster. You would be doing all the operations like creating file, deleting file, all the basic operations here on chapter 7. And on chapter 8 you would clone all the clone machines on VirtualBox, and you create a cluster CentOS machines. You'll clone all the CentOS machines and you'll create a cluster. Okay, and one more important thing, guys, I just wanted you guys to make understand about CentOS, the importance of CentOS. Okay, how many of you have heard about distributions, guys? Hortonworks, Cloudera, Mapr. I guess most of you would have heard of distributions, because when you get into companies, most of the 3-tier, 2-tier companies would be using distributions, because all the small startups, they end up using open source. But if you get into big companies, 2-tier, 3-tier companies, they would be using distributions. So I just wanted you guys to understand that distribution is nothing but the Hadoop tar file. There's a Hadoop tar file, and on top of Hadoop tar file, they have added n number of functionality, that is attractive GUIs. They have all those things. Okay, so all the distribution would be coming along with CentOS, guys. So Cloudera comes along with CentOS pre-installed. Okay, Cloudera is pre-installed on top of CentOS. Hortonworks is pre-installed on top of CentOS. Okay, so they have installed CentOS on their distribution. So it is very much important for you guys to work on CentOS, because if you get into company, again you're going to work on CentOS if you are forced to work on distribution. Okay, so that is how CentOS will come into picture. So the importance of CentOS. So I was just stating earlier, I'm grateful to Arun that he came up with the idea of installing CentOS, and that is actually a good approach to start with. Okay, so make sure you have CentOS installed. Fine. Okay, so by this point you would be in a position to install cluster, and then by chapter 9 you would be in a position to work with metadata. You would be knowing like where is the metadata stored, the importance of metadata, what are the extra provisions that you need to take to safeguard metadata. Okay. And then chapter 9, moving forward, chapter 10. Cluster maintenance and troubleshooting. Okay, now it's simple. It's like a story, guys. You need to understand from the point of a story. We started off with big data, the problems, and then what is the solution to big data, the Hadoop, and then installing everything. You have everything installed. Okay, after everything is installed, when you start using Hadoop, what happens is you end up with lot of problems. Problems in the sense something might go down, something might fail, some data is lost, or n number of problems. There are a lot of problems that might occur. Okay, and in Hadoop, especially in Hadoop's case, you won't get the same problem again and again. The problems will differ, because this is not about one computer, guys. This is about n number of computers connected in different routers. Your data is residing in racks, and then racks are interconnected. In one rack you have one router you would be having 20-30 machines. So you'd be, let's say one rack is having 20 machines. If you have 10 racks, then it's somewhere around 200 machines. So just imagine the complexity of the problem. And you're going to work on 200 machines. You should make sure that 200 machines are working in sync. It's a huge responsibility. Huge responsibility in the sense the probability of problems coming in is lot more compared to Linux or Oracle DB administrators. They don't have that liberty, right? You guys are going to work on n number of machines. So when you add on machine, complexity will obviously increase. You cannot expect the complexity to go down. As you add on a new machine, the complexity will increase, because you are going to integrate a new machine, new problem. So this is how things goes. So all the problems, you cannot expect the same pattern, guys. In Linux administration, most of you would have seen that there is a pattern. Like if this goes down, this is the solution. In Hadoop, you cannot expect a pattern. I mean, it would differ. Sometimes the memory of one machine might go down. Then you need to find out which is that machine where the memory is gone down. Then you need to troubleshoot it, find it, fix it. Or if you're not able to troubleshoot it, you need to move all the data residing in that particular fault machine to a new machine. So there are a lot of things coming into picture. So this is the core part of an administrator, that is troubleshooting, cluster maintenance, making sure everything is working fine. Nothing should go down at any point. If anything goes down, you will be held responsible. Okay. So this is where the FSCK is file system check, and then balancer, then getconf. So these are all the commands through which you can troubleshoot and make sure everything is fine. You don't have that attractive GUIs where Cloudera has. Cloudera, Hortonworks, you can just click on Hue. You have Hue in Hortonworks, you have Ambari. So you can just click and you will get to know everything in very attractive GUIs. You don't have to take the trouble of typing the command. But here we don't have those attractive GUIs, guys, because we are not working on distribution. We are working from the scratch. Any troubleshooting needs to be done. You should do it via command prompt. You don't have those attractive pie charts and histograms showing the amount of data or the amount of complexity. Nothing. Anything, if you want to troubleshoot, everything goes with command. Command, you need to find out the issue. Command, you need to fix the issue. So that is the importance of command. And you're going with minimal installation of CentOS where you don't have that attractive GUI for the operating system as well. You don't have those attractive GUI in the operating system. You will have to go with command. So there's another plus point with that. I was discussing the same with Arun other day. So what is the add-on advantage, guys? Many of them like they ask, I mean, I'm sorry. Many students come up with the same doubt. Like many of them ask, like, if you are getting into a company and if the company is having Cloudera or Hortonworks installed, why do we have to take the pain of doing everything on the command prompt? A very valid question, $1 million question. How many of you agree with that, guys?
Yes, Hortonworks has like Ambari, right?
Correct.
Same stuff.
Correct. So many of them come up and they ask, like, why should we take the pain of learning everything from the command prompt when we can do everything on Ambari or on Cloudera Manager? Everything has attractive GUIs installed. Why should we take the pain of doing everything from command prompt? To be frank, working on command prompt really pains, guys, because you don't have those attractive GUIs. You can, to understand everything, you will have to go via command prompt. I mean, so it really pains. So I'll come to the point, like, why are we doing the particular thing? We could do a training on Cloudera or we could do a training on Hortonworks. It's as simple as that. Hortonworks and Cloudera are free. We can download the sandbox and we can take up training on Cloudera or Hortonworks. Why are we stressing on the Apache Hadoop? Anybody, why are we stressing on Apache Hadoop, guys? We can take up training on Cloudera and Hortonworks, right? Why are we stressing on Apache Hadoop? Anyone? No idea?
Means you're asking like why the companies are stretching up, or like
no, why we are taking up trainings? Why we take up trainings on Apache Hadoop? We could take trainings on Cloudera, right? Or we could take trainings on Apache. On Hortonworks.
Okay. It means in that case, right? Suppose it's all like pre-installed, right? We never face any issues. Correct. Or even like in real time, if you face the issues, we can't figure it out unless we do it in Apache Hadoop. It's good. Like
very good, Umar. So that is the root cause of the problem. Okay. So when you have everything installed, when you have everything pre-installed, where is the chance of learning, guys? I mean, when you have everything pre-installed on Cloudera and Hortonworks, what is the point of training? How will you get to know what happens behind the curtains? If you want to know what happens behind the curtains, you will have to get behind the curtains and then see what happens. Then you can move ahead and then you can go with distributions, then you can work accordingly. The whole point here is to understand what happens behind the curtain, guys. So that is the reason we go with Apache Hadoop. When you install Apache Hadoop, you don't have to, I mean, you will have to go with command prompt. If something goes down, see the port number, fix it. I mean, and when you get into, so let's understand this. When you get into distribution, it would be a cakewalk for you. I guarantee you on that part. When you get into distributions, it would be a cakewalk for you guys. because you know everything. I mean, you know the stuff that happens on the background. So it would be a cakewalk for you guys to work on distributions. I have personally experienced that particular thing, and I'm pretty much confident on that part. Okay, so that is the reason we go with Apache Hadoop, guys. So we don't have that liberty. We don't have that liberty of GUIs, but initially it would pain. But as you get used to it, you will find it very much interesting, guys. I can guarantee you on that. Okay, moving ahead. Chapter 11. Chapter 11 is all about commissioning and decommissioning. Okay, commissioning and decommissioning of nodes. I'm sorry, guys, we are again stretching out of time. It's 9:29. We'll stretch for another 10 minutes, guys. I'm really sorry. I understand you have your own work. I mean, I really appreciate the patience that you have. We'll stretch for another 10 minutes, guys. 9:40, we'll close. Fine? Okay. So chapter 11 is all about commissioning and decommissioning of nodes. Okay, commissioning and decommissioning is nothing but adding and removing a node. Okay, adding and removing a node on the fly. Okay, so I've written it on the fly. On the fly means you cannot expect the cluster to go on downtime. Okay, have you ever seen Facebook going down? For no reason, you would have never seen Facebook going down. All the point Facebook is up. The reason, because they have some provision. Everything happens on the fly. They cannot shut down Facebook and do all the configuration, right? It cannot happen in real time. Think from the real time perspective. You cannot expect the cluster to go down at any point. The cluster should always be up. You should do all the mechanism while the cluster is running. So that is on the fly. Okay. So we remove and add nodes on the fly. So that is all about commissioning and decommissioning. And chapter 2 is the most important chapter, guys, because this is where you're going to, we will be introducing you to all the issues that we have faced. So we have been, coming to my personal experience, I've been working with this particular architecture for 2 years. So I have encountered a lot of problems. So what I did was I have documented everything. So we'll share those documents. What I expect from you guys is you create a trap first. You create a trap, you get into that trap and come out of the trap. So that is what you need to do. I mean, when you get into companies, you find a trap, it would be very difficult to understand. So creating a trap in the sense, creating an error all by yourself and fixing that error all by yourself. So you understand how the error occurs and what are the contents. By seeing the content, you should be able to fix the error. So that is how it goes. So we'll go through this particular topic in detail. We'll see all the errors that is being faced in real time, and we'll try to work on those errors. Okay, we'll see how to fix the error, we'll see how to troubleshoot it, we'll see what are the mechanism that needs to be done. There is a turnaround time for everything, guys. You cannot when a ticket is raised, okay, there's a ticket raised from the developer. So every ticket has a TAT, turnaround time. There is a turnaround time for the issue. You cannot sit with that issue for the whole day. Administrators are expected to fix the issue with a turnaround time. So everything comes with a time span. So it should not be like, you should have the skill to fix everything within that time span. So you should be used to, you need to get used to all this command prompt and all those things, right? You need to get used to the error. You need to get used to, you need to understand the error by seeing the pattern. So there are a number of things coming into picture. So my point here is there is a turnaround time for every issue. So you should be in a position to fix the issue within that. For that, you need to understand errors, understand the pattern, try fixing the errors. So it's a whole long story. We'll get into that in detail. Okay. I'm sorry. So chapter 13, it's HDFS federation. Okay. Federation is nothing but federating your cluster. Federating your cluster in the sense. Okay. So I'll explain it with an example. So you are just imagine that you are working as a core Hadoop administrator. Okay. Now there are n number of departments in company. You have an HR department, you have sales department, then admin department, marketing, development, then testing. It would go on. Okay. So what the company expects, okay, the company is expecting from you that you segregate the department data, you federate the department data. That means you segregate the data depending on the department. So I will keep it simple. HR department data should not be having the marketing department data, or marketing department data should not be having the sales data. Sales data should not be having the developer data. So what you do is you federate the cluster. Federate means you divide the cluster. HR, you divide it. Let's say you have a 100 GB data, okay, and you have 2 departments, okay. In this point, okay, by this point, what you learn is you have a 100 GB data, and if you have 2 departments, you will not be in a position to segregate it. What you do is you dump sales along with marketing. So that is what that will happen in chapter 8. You will not be in a position to segregate it, okay. This is next level of cluster installation, okay. What you do here is you by this point, by the completion of chapter 13, you would be in a position to divide the data according to department. The data will not switch. Marketing data will not be having sales into it. Sales will not be having marketing into it. You allocate, let's say you have 100 GB of cluster capacity. Then if the requirement is share the data for 2 departments, what you do is you assign 50 GB to marketing and assign 50 GB to sales, and make sure that all the data loaded by the sales department should be residing in the sales 50 GB. It should not go to the marketing 50 GB space. Okay, so that is federation. You federate according to the requirement of the client. Okay, so we'll get into those scenarios. We'll understand that clearly. Okay, high availability and automatic failover practical with Zookeeper. Okay, so this is all about automatic failover. What is automatic failover, guys? Automatic failover in the sense, as I stated earlier, this is all about metadata. Chapter 14 and 15 is nothing but safeguarding metadata. Okay, safeguarding metadata in the sense you have a name node, which is nothing but the master of the cluster. Okay, so if at any point, if the master goes down, the cluster is downtime. I mean, the cluster goes into downtime. You cannot access the cluster. So by the end of chapter 14 and 15, you will be in a position to set up a high availability cluster. That means if the name node goes down, you would be having a standby name node. The moment name node goes down, the standby name node will come up and it will act as active name node. So what happens is you will have 0 downtime. In high availability, you can configure n number of name nodes. Let's say if the name node 2 goes down, you will have name node 3. Name node 3 goes down, name node 4. Depending on your requirement, you can configure n number of name nodes. So that is all about high availability. And last chapter is automatic failover. Automatic failover in the sense, administrator, let's say, I'll make you this understand with a small example. Okay, so you have configured high availability. Okay, what is high availability? If the active name node goes down, the standby will come up. How will it come up? The administrator will have to make it up. In this case, chapter 14. In chapter 14, the administrator will have to make it up. If the administrator is not going to do that, it will not come up automatically. So let's say the administrator has gone for a lunch break, 1:30. Okay, after on 1:30, the administrator has gone for lunch break. Okay, so what happens is the name node goes down by 1:30. Okay, the administrator won't be having any clue what happened. He will be having his lunch happily. He'll come by 2 o'clock or 2:30. What happens is the cluster is downtime. The cluster goes to downtime, like 1:30 to 2:30. It's downtime. Clients won't be able to access the cluster. So that is the problem with manual. You cannot do that manual. So what they came up with the idea of automating that particular thing. That is automatic failover. Automatic failover can be done with a tool named as Zookeeper. So we have Apache Zookeeper, which is an open source tool. You install that open source tool along with the cluster. So what happens is at any point the first name node goes down, the Zookeeper will make the standby name node active without interruption. Admin can take a back seat. He can relax. Zookeeper will take care. Okay, so that is all about 15. And then we will be having some sessions on, we will be having some mock interviews. We'll take up some mock interviews, we'll give some interview tips, we'll work on distribution. We'll have one session on Cloudera distribution where we'll show you a demo on how everything works from Cloudera. So I guarantee that you'd find it very easy when you work on distribution. We'll be having some sessions on interviews as well, tips for interview. Arumugam would be coming over and he'd be sharing experiences on interview, what are the expected questions. So we'll make this interactive. Okay, and one more important thing that before I close, one important thing I have to make sure is make sure that you guys don't scribble anything on Notepad while we are handling. Okay, I am not able to view what happens, right? In classroom, I can just view and I can get your attention. When in video, it is very difficult for me to get your attention. Okay, so the only thing is I can trust you guys. Okay, so make sure that you don't scribble anything on notepad. We have everything well documented for every session. Okay, everything is well documented. So once the session gets over, chapter 1 gets over, we'll be sharing the documentation via Gmail. Okay, so you don't have to write everything and you don't have to remember all those things. Just make sure you concentrate on the session, guys. Just concentrate completely on the session. Don't write the documentation. Or I have seen many of them spend half of their time in the session writing documents. What happens is they won't be getting that sync and they'll completely lose the sync. So I don't want that thing to happen. We have documented everything very well. So what we'll do is, after completion of the session, that is after completion of chapter 1 or chapter 2, we'll be sharing the document. So you can just view and you can understand all the topics that we have discussed would be there in the document for sure. Okay, so hope I'm making sense. Feel free to raise queries, guys, if you have any, please.
Yeah, Bashir, like you told, like if there is a like automatic, failure happens. Okay, if the name node goes down, the standby node will come up.
Correct.
So it come up. Once it's like goes down, will there be any notification, like any monitoring tool, like will get notification? Okay, it has gone down and the standby node is active.
Yeah, we can have that notification in the web GUI. We have a web GUI for name node. In the web GUI, you will get to know that the name node has gone down. The name node has gone down. Sanjay, could you just mute your mic? Okay. Yeah, Arun.
Okay.
Basically, like quick question, like
yeah, please.
You were like that each chapter was very detailed and it very good, but I like to know, like, if any certification is there.
No,
it's in market, you can prepare.
No, we don't take up, sir, to be frank, we don't take up sessions considering the certification thing. I mean, you can take up certification if you're willing. If you're willing to,
you can recommend anything.
Yeah, you can go with Cloudera certification. I mean, I have seen going with Cloudera, and Cloudera is pretty much a decent certification, and it is not that easy to crack. So you will have to do a lot of homework from your end. But once you crack it, you have that reputation outside market. So Cloudera certification is recommended.
Okay.
Okay, Arun, coming to a question, guys.
Yeah, that's what. Like, we'll be having like a notification kind of thing. Like the primary name node had gone down.
We have that notification. We have that notification in the web GUI. We have a web GUI for name node, right?
Okay.
So we get that notification in the web GUI that the name node has gone down and the standby has acted up and it is active right now.
So again, like, do we need to bring up the name node?
That is what in chapter 14 the administrator will have to make the standby active. Okay, there is no automatic thing installed in chapter 14. In chapter 15, you have a tool named as Zookeeper, which will take care of the issue and it will make the standby active without the knowledge of the administrator. The moment the first name node goes down, Zookeeper will get an intimation. Zookeeper is nothing but a coordination server. So the coordination server is installed on both machines, that is both name nodes. So we have a token system. So there's a token named as ZKFC. Let's not get into the core part. We'll just understand from a higher level. So we have a token named as ZKFC, that is Zookeeper Failover Controller. So we install the token on the primary and the standby name node. The moment the primary goes down, the token will intimate the standby that you become active. So within a fraction of a second, the standby will become active and it will start serving the client.
Okay, I got it. Thank you. I got your point.
Okay, fine, guys. So I'm really sorry we had to stretch. I was supposed to close the session by 9. Unfortunately, that didn't happen. But I'm glad that you guys have really patiently waited, and I really appreciate that from your end. So make sure you before we start the session, we have scheduled our session on 4th of August. Yeah, on 4th of August, that is Saturday. So we have scheduled our first session on 4th of August, that is on Saturday. So make sure you are ready with 4 GB of RAM. The minimum configuration for the course is 4 GB of RAM. Okay, you should be having 8 GB of RAM. 8 GB of RAM, and install minimum 1 clone. Okay, we'll go with 3 clones later. For time being, install 1 minimal installation of CentOS on that particular machine, laptop. Okay, just install 1 clone and be ready with the course. And I mean, everything is pre-documented, so you don't have to document anything, as I stated earlier. And coming to certification, as Umar had asked, a certification is depending on the candidate. If you are willing to take up certification, you can take up certification, but then again, it is from the perspective of Cloudera. Cloudera, in the sense, they would be taking up, they would be asking questions from their distribution, from their point of view. That would slightly differ, but you will have to work on Cloudera from your end. Okay, we won't be. Okay, so Arul has asked to provide CentOS VirtualBox link to download. Yeah, I'll send it, Arul. I'll send it, Arul. I'll send it. I'll share the link, guys. So you can just click on that particular link and you can download it. Okay. Yeah. Thank you. Okay. So Umar, you can take up trainings on certifications if you're willing. So you will have to work with Cloudera Manager. So Cloudera distribution is free of cost. You can download it and you can install the Cloudera setup on your VirtualBox, and then you can work on Cloudera. Okay. So you need to get used to Cloudera Manager. So in Cloudera Manager, there are n number of buttons and n number of checkboxes. So you should get used to Cloudera. So that is the main concept here. So you should get used to Cloudera for clearing the certification. It is not just Hadoop. So it is not about Hadoop. It's about Cloudera. If you take up Hortonworks certification, you are expected to know about Hortonworks. So their environments will differ. It's like distributions, like in Linux. Ubuntu distribution will differ from Red Hat distribution. So if you're going for Red Hat certification, you're expected to know about Red Hat. Same goes with Cloudera. You're expected to know about Cloudera. Hadoop knowledge is not enough. I mean, you'll have to learn something on top of that is about Cloudera distribution. And I presume you can do that all by yourself if you have a clear understanding of Hadoop. Am I making sense, guys?
Yes, yeah, sure.
Okay, guys. So thank you for the session. Feel free to reach me at any point if you still have any queries. I'm really sorry I won't be able to take up any queries further as we are running short of time. So feel free to ping me. You have my contact number. So you can ping me at any point if you still face any difficulty in installation of CentOS. So you can ping. I'll send you the link across. You can click on that link and download the ISO image. So installation is pretty simple. Download the ISO image on your laptop, and then you need to clone that particular ISO image to the VirtualBox. Okay, so you can go with Oracle VirtualBox. So I'll send you the document. How to install it on CentOS. So I'll share the link as well. Fine. In case if you find any difficulty in installation, feel free to reach me at any point. I'll be there to help you out. Okay. So make sure you have it ready by the start of the session. Okay. So thank you guys for your time. Hope you are clear with all the concepts. Fine. So we'll close the session for time being. Okay.
Sure. Thank you.
Thank you for your time, guys.
Thank you.
Thank you. Arun, you have any queries?
No, as of now, everything is fine.
Okay. Yogesh, I guess Yogesh is online.
No, I don't have any doubt. Thank you.
Okay, fine. Thank you, guys. Thank you for your time. Thank you. We'll be sharing the recording on the Google Drive, so you can go through the recording as well. We'll be sharing it and we'll let you know about the recording. Okay.